Hello, I'm Karen, an engineer on the Android Developer Relations team. In this talk, my colleague Anastasia and I will tell you all about the new developments in accessibility for Android developers. We'll touch upon improvements in Android Studio, new APIs, and advances in Jetpack Compose. It's important to remember that accessibility is an important part of any app, and by integrating accessibility features and services, you can improve your app's usability for all users. Let's start by looking at improvements in developer tools that'll help you build more accessible apps. To help you detect ways to improve the accessibility of your app during the development process, Android Studio now contains built-in checks to help make your layouts more accessible. When using the layout editor, you can now click on the Issue Report button to see accessibility-related issues detected by the Accessibility Test Framework. Accessibility Test Framework is the same library that's used to detect issues with the Accessibility Scanner app or when accessibility checks is enabled in Espresso tests. Studio may even be able to offer suggested fixes for key issues of accessibility, such as ensuring each UI element includes a description readable by screen readers. Interactive elements, such as buttons, are at least 48 dp large in both dimensions. And sufficient color contrast to make text and images easier to read and comprehend. This integration currently only works for view-based layouts, and we're working on making it compatible with Compose as well. In addition to the new accessibility checks in Android Studio, we've introduced a new API that'll make it easier for users to consume videos with audio description. Audio descriptions are narrations added to video content that allow visually impaired users to better understand what's happening on screen. So, if you work on an app that has video content and the app supports descriptive audio tracks, this API is for you. Starting in Android T, there is now a global preference that users can turn on to enable audio description by default. With this default setting, users no longer need to change the audio track for every video consumed and can have a more unified experience across all apps, especially when consuming content on TV. This means that if your app serves video content with descriptive audio tracks, you should now utilize the Is Audio Description Requested API to determine whether the user prefers to play video content with the audio description track.
Hi, I'm Anastasia, an engineer in the Jetpack Compose team. Let's go through some of the improvements that we made in Compose and Android Studio to help you build an Android app that is accessible to more people. Compose is a modern declarative UI framework for Android. It has been developed with accessibility in mind. Where possible, Compose fills in accessibility information by default. An example of this is Compose setting the minimum touch target size. Any on-screen element that someone can click, touch, or interact with must be large enough for reliable interaction. On Android, we recommend touch target sizes of at least 48 by 48 dp. In Compose, material components like checkbox, switch, icon button, and others that can receive user input use this minimum size by default. Let's have a look at a radio button. We pass a non-null on-click callback, which means that this radio button can be interacted with. Even though visually the icon is only 24 by 24, patterns have been added so that the real size of the composable has been increased to meet the 48 by 48 minimum touch target requirement. If, however, we set the on-click callback to null, the size of the radio button is not increased. In this case, the radio button is decorative. It can't be interacted with and therefore can keep its original size. If the layout size of a non-material interactable component is too small, Compose also has a fallback feature. It will expand the size of the touch target only. When the touch happens outside the boundaries of the composable but within the minimum touch target area, Compose will forward the touch input to be handled by that composable. Note that if there are multiple interactable components adjacent to each other, there may not be enough space to satisfy the minimum touch target size. Therefore, we recommend you either size your interactable component to be at least 48 by 48 dp or ensure enough space between the interactable components so their expanded touch targets do not intersect. To ensure consistency for all components, you should be using the minimum touch target property of the view configuration composition local to define the minimum touch target size for your components. Compose uses the value of this property to set the touch target size of the interactive components and the minimum size of the interactive material components. I mentioned that Compose fills in accessibility information by default, but that's not always possible. Sometimes Compose as a framework doesn't have enough information to feed into the accessibility services. Accessibility services are long-running privileged services that provide different ways for users with disabilities to interact with your app. Google provides several accessibility services such as TalkBack and Switch Access. To learn more about the commonly used accessibility services on Android, check out android.com/accessibility. Without the necessary information, accessibility services can't meaningfully convey to the users what's displayed on the screen. In Compose, we sometimes ask you to fill in such information. Our APIs are written in a way that guide or even require you to consider accessibility during app development. For example, as a general principle, you should label meaningful UI components like icons that accessibility services can't automatically describe. Therefore, in Compose, we made content description a required parameter in image and icon composables. When the image is purely decorative, you can choose to set the content description to null. This API provides the most natural way for you to express what makes the most sense for your use case. We've seen how sometimes you need to pass extra information to the accessibility services and how Compose APIs help you with that. Let's now take a look at how Compose uses this input and how you can debug it. In Compose, your UI is stored in a layout tree. However, this layout tree doesn't contain any information about the app's semantics. Semantic information explains the meaning of your app. You can think of it as an alternative representation of the user interface understandable by the accessibility services and the testing framework. Therefore, in addition to a layout tree, there exists a parallel semantics tree that contains this information. Compose uses this semantics tree to send information to the accessibility services. On Android, it does so by mapping a semantics tree to the accessibility node info tree of accessibility framework. A composable function that emits a layout node will have its representation in the semantics tree if semantic information is provided via the semantics modifier. Inside the modifier, you pass semantics properties. Let's have a look in one of them, a role. Roles are used in some of the components like buttons and checkboxes to describe what they are. The role variable is a convenient way to set the role semantics property. It uses the property delegation. Looking at the setValue method of the delegate, we noted that all it does is set the value for the given key. In our example, it set the role button to the role key. So semantics properties are key value pairs that describe the meaning of the component. Some other semantics properties in Compose include focused, state description, live region, and actions like onClick action. One layout node might have several semantics modifiers applied to it. Each of them could provide the same or different semantics properties. Semantics data from all semantics modifiers is then collapsed into a single key-value storage that we call semantics configuration. For example, when we call a text composable, it already has the necessary semantics properties. When we pass additional semantics with the heading property to mark this text as a heading, the resulting configuration contains the property that was set implicitly inside the text composable and the heading property that was set explicitly. This happens because the semantics applied to a single node are collapsed. Each layout node with the semantics information will have a corresponding node in the semantics tree. But such a tree might not necessarily convey the correct meaning of the user interface because some of the subtrees hold the meaning of a piece of UI only as a whole. Therefore, to ensure that such subtrees are treated together as single units, we need to merge the nodes inside these subtrees. A typical example of merging in Compose would be a button. Here, it consists of two semantics nodes. One node contains the semantics property that describes the button as its click action. Another node represents the text. But only together these two nodes convey the meaning of the submit button. Therefore, we need to merge these two semantics nodes into one node. Here is another example of the merging. This UI represents a clickable card with a few texts and an image. if there wasn't a merging mechanism, an accessibility service, a screen reader for example, would focus on each node separately. But because these nodes as a whole convey a meaning of a card, we'd like the screen reader to deal with these nodes as a single unit. To achieve this behavior, you should pass true to the merge descendants parameter of the semantics modifier. Let's have a look how the merging is done. The light gray rectangles represent the nodes that don't merge descendants, while the dark gray represent the nodes that do. During the merging, the framework will add semantics configuration of descendant nodes that don't merge descendants into semantics configuration of their parent node. That way, the parent nodes with merge descendants set to true accumulate the properties of the descendants, and these descendant nodes are then dropped. Nodes that themselves have a merge descendants property set to true will not be merged into parents. As a result, the merge semantics tree will only contain the representation of the layout nodes that merge descendants themselves. In this example, the row and the inner bookmark button use the clickable modifier. Under the hood, this modifier set the merge descendants of the semantics to true. On practice, it means that the accessibility services, a screen reader for example, will first focus on the whole container, and then separately on the bookmark button. The merging is happening according to the merging policy. We define the merging policy separately for each semantics property. As you can see, the merging policy resembles the reduce function of the Kotlin collection. Here are a few examples of the merging policies for the existing semantics properties. For most of the semantics, we pick the parent value if one exists, or otherwise use the child value. For some, though, we use the parent value only, like in the role semantics property. Some semantics properties concatenate parent and children values into a list. Some throw an exception if the property cannot be merged. It means that the node that has this semantics property must not set merge descendants to true. As I said earlier, Framework provides semantics information whenever possible, but you may encounter a use case where you need to clear the existing semantics of the component or its children and provide your own alternative properties. Note that this shouldn't happen often and might even be an indication that the user interface you are building is not as accessible as it could be in the first place. So let's have a look on a typical example where you might consider clearing the semantics. Imagine there is a UI showing a long list of items. A typical example would be an email app or a news app. In this example from the Jet News sample app, there is a list item showing details about an article. Clicking on the list item will take you to the details screen for this article. It also has a toggle button that allows to bookmark the article. The list item merges semantics and so does the toggle button. So if we use the screen reader like Teckykk, it will first focus on the whole item, and then it will navigate to the bookmark button. If the list is long, it might not be a good experience for the user. Instead, we would like Teckykk to focus on an item and have a bookmark option available as a custom action. To clear the semantics of the bookmark button to prevent it from being separately focused by the screen reader, you should use a clear and set semantics modifier. Similar to the semantics modifier, you may pass semantics property via this modifier. This modifier prevents collapsing any semantics of the given node coming after this modifier and merging of any of the children of this node. So you have a chain of modifiers applied to a layout node, including the semantics modifier, and you pass a clear and set semantics in between them. You can think of a result as if the resulting chain didn't have any semantics coming after this modifier in the modifiers chain. Starting in Android Studio Bumblebee, we can inspect the semantics tree and semantics configuration using the Layout Inspector. Note that the inspector provides two options for the semantics representation: declared semantics of the unmerged semantics tree and merged semantics of the merged semantics tree. To recap, in Compose, in addition to a layout tree that represents the UI, there exists a parallel tree that carries semantics meaning. When you develop an app, make sure you test it on several commonly used accessibility services. If you encounter any missing semantics information, you can provide it either via the common accessibility APIs available in Compose or by applying techniques discussed in this talk. To learn more about the most common accessibility APIs available in Compose, go check the Google I/O 2021 session Designing for Accessibility in Android Studio and Jetpack Compose. And that's it from us for now. Thanks for watching, and be sure to check out the resources we've included in the links below to learn more about what we've covered in this video.